Hello and welcome back to the guided project for the house prices in the Kaggle competition. So going to the modeling section, so as we've discussed, we have lots of features. And so what I do here in this next section is make a list of all of our features. So we're going to reduce these, but I start with feature one and I just iterate through this list and copy and paste the list here. And so I just select out the handful of features that we identified up above that we're not going to use. So we didn't want to hot encode them, so they're not really valuable to us in a sense. So commenting them out, I like to leave them just so I know which ones I've taken out, just so I can be conscious always of what's going in and what's not to my model and what am I leaving out on purpose to hopefully improve my model. And this could always be good. This is a quick way just to give access to your features before you put them into your modeling. We're going to use SHAP values to try and decrease this. Now, this takes a while to run, so I won't run it today. But what we'll do is we're going to import it. So you do SHAP values, and you'll go pip install SHAP values, pip install Optuna, and you'll need both of those to work with the SHAP function. So then after we run them, after we import them, and you even have to do this on Google Collaboratory, they're not specifically available all the time. That will probably change in the future. So we'll then import SHAP and Optuna. And what we're going to do here is we're going to do our train test split. So we'll start off, so we're going to write a function, SHAP summary plot. We're going to give it features equals 1, target equals target. And so our features in this data set will be features 1, our list of features up above. Okay, so we'll start with our train test split. So we'll do x train x test, or sorry, not equals y train comma y equals to train split, train test split. And we're going to give this the x and the y that we've assigned from just the lines above, x, y, and here what we're going to see, you can see test size equals to 0.3, so we'll do tests size equals test size. So you can change this if you wanted to in the function down below. Test size equals test size. And then what we'll do is we'll do random state equals, and I always like the 42 because that's the answer and the meaning to everything in life. And so here we're going to import the standardizer. So this is very important for your data. So this is something that's kind of like a must do. And I always think it's like going into your model is the scaling of your data. And so this is almost a part of your model in the sense is the standardization. And then the PCA is that we'll do in a second here. So what we have is standard scalar. And what we're going to do is we're going to go standard scalar. And we'll fit it just as we're importing. So we're going to fit it on X. Oops. Dot fit parentheses x train. So we'll fit it as we import it. And then what we're going to do is we're going to standardize. So we'll go x train equals to standard scalar, the object we've assigned, dot transform. And then what we're going to do is we're going to transform x train. And then make this a little easier, we'll just copy and paste this line down below. Just make sure the indent is the same. Python is very sensitive to the indent. I like doing the train and test syntax or assigning the variables this short form because then you only need to change one character. You'll find you'll change quite a bit between train and test, and it's just a little bit easier to do it that way. Just change one letter at a time. So what we're going to do, okay, so that's great, we did that. Now what we're going to do is we're going to turn those back into data frames. So that we can have our names of our features as we go into the pipeline so that we can really understand which features are having an impact so they can be labeled which features. Okay, so here what we're going to do is we're going to go x train. We're going to go pd dot data frame. And what we'll do is we're going to give our x train our data frame, and then we're going to go columns equals x columns. So our columns from up above. And we'll do the same thing for our x test as well. And so this is taking the original columns from the data frame or that we've reduced, that we've chosen, and then we're going to change x test here to, or x train to x test. I really do like the short form. It's just a little bit easier because one thing you always have to change is the train and test. So it's just a little bit easier to do. So we'll do that. And next we'll do the chap summary. So this is what we'll do here is we'll do x train summary. Summary is equal to chap dot k means, and what we're going to do is we're going to give it our x train, and then we're going to split this into, we're going to use 10 means. So, and so I did this the long form the first time, so we'll change this train to the short form train. And what we're going to do, our model is going to be ARD regression in these ones. We're going to stick with linear regression. The first thing we're going to do here as well is we're going to assign PCA is equal to PCA. See, it's just like we do with the standard scalar. And then we're going to fit this when it's in the pipeline, so we don't need to fit this right now. So we see our X train and our Y train is done there. Our model is again assigned from up above, and you'll have the ability to change this. So here what we're going to use is we're going to use the explainer. So we're going to use the kernel explainer. And here what we're going to do is we're going to get our SHAP values after we've assigned the explainer from our test train summary. We're going to get our explainer, and we're going to, just like this, we're just going to get our SHAP values now from the explainer. So SHAP values, perfect. Okay, and let's just make sure we change this. And changing this right here as well. So just changing those DAX tests, we just got to make sure that we're staying with the same syntax and writing that we had originally. You often change their style of writing as time goes on. So here we'll assign our function. Our function's good to go. And we have a little bit of a different indent I'm noticing right here. And so it's just these ones right here are a little bit not out of line. And so now everything is in the same line. Very, very important that you keep everything in the same line. Here, and you can see that was why these were red, kind of showing up red here, and this one's still showing up red because it needs to be changed to TS. Okay, so just changing that. So we'll run that, and because this takes a very long time, I'm not going to run this today, but I'll show you what I did. And so this is the SHAP summary plot, and it looks truly, I think it's very pretty. Here, what we can see is our overall quality really has the biggest impact on the final output. Greater living area, second floor square footage, first floor square footage. These really have a big impact on our model, and these are what these are. If you go down to the very bottom, because we have so many features, these are the impact on the final value of the score. So this, if you're including it, if you're not, the color denotes if the value of the feature, if it's pinker, so the value of the feature would be high. So when this value of the feature is high, it's adding value, and when it's low, it's taking away value. And so you can see here when greater living area is high, it's adding value. And then when it's low, it's taking away value as well. So way to interpret it is very, very interesting going through this and really understanding your model, because especially with ensemble methods, with linear regression, it's easier to interpret. But even when you get to basic ensemble methods, it starts to become much more difficult to really understand what your model is doing. The way that I use this is you can see that there's many features at the bottom here that really have no impact. There's some that have a negative, only show a negative impact. Again, negative, a little bit of a positive. So what I do is I'd go up to right here and I'd remove all of the columns down below, and I've done this for you. I'm a nice guy. So I made a list, and then what I did is I copied and pasted the list from above, and I commented all these out. It was a little bit tedious to do, and I tried to do them in batches of 10 or 20 to get started. And then as you get further up, you'll find as you take away values, the effect the remaining ones have will change. And so it's good to kind of get up to a certain level, maybe somewhere where you're not where they really start to have a positive impact, and then see if that holds true after you removed all of the features up to that point. And they really will change. So it's good to kind of do a good chunk. There's lots here that probably will just not have an impact, but then afterwards, as you start getting up to the features that have more of an impact up here, you really want to kind of go slower and be more iterative. It's a little bit tedious, but this is, again, for a competition. So you got to go the extra mile, right? So here's all the ones that I took out, quite a few. And I really just felt they did not have a value and they didn't really seem to add a value. And I would take them out here, comment them out, and I'd rerun the SHAP plot, again, putting in features 2 here, this reduced list, and we can see the impact. And I was just going to the ones, really just eliminating it until we can get up to only the ones that are adding value when they occur, and trying to not include the ones that are showing low values. And this is used resampling. It's not done a million times, so this is just a representative of that sample. And so that might be true sometimes, it might not be true all the time. And so this is very reflective of the train test split that was drawn. But I found that in general, when we do the cross validation score, that this one does actually help. And so it is kind of an iterative process to see. And it's good to find out which ones do have an impact. But follow the SHAP value indicator. So this one is taking away 50,000 or adding 50,000 to the final value. But it's very much an iterative process, because the relationship of the variables, they interact with each other to predict the final target. So as you start removing them, especially removing the higher quality ones, it becomes less clear kind of which ones you'll actually need to remove after you've removed a few of them. So going through that, and then what we're going to do is just do a couple of other little things, and then we'll go into our final section.